Hi, this is the orange tornado experiment, and it will demonstrate the concepts of equilibrium and solubility with an emphasis on Le Chatelier's principle. And as you notice, the experiment is pretty small and contained, and originally the write-up for the lab would have produced much more mercuric waste, but we reduced it so that it only produces about 800 milliliters as opposed to 4 liters. So right now you can see that this is just distilled water, and there's a vortex which is being created by a magnetic stirring rod in the bottom. And I'm going to go ahead and add some mercury 2 nitrate to the center. And we're just going to let it disperse throughout. And I'm going to turn up the vortex a little bit.
Now I'm just going to add a few drops, as long as we'd like. Now that's the nice orange color we're going for.
So the Chatelier's principle tells us that when we shift the equilibrium by adding something like increasing the concentration of a reactant, which is what we're doing by adding more Ki, the equilibrium of the system will shift to compensate.
And in this case, it's shifting towards the products. This is the mercury 2 nitrate, which was already in the beaker, and this is the Ki that we added. This is the solid that you see. Notice you only see in the vortex for a short time, because at that time the concentration of the solid is greater than the concentration of the reactants, but only in the vortex. Once it escapes the vortex, the reactants are in greater concentration than the solid. That's why you have.
So you can see that as it goes in, the concentration is very high and concentrated in the bottom of the vortex. Therefore, you see the color. But as the reaction proceeds, the color disperses and it's invisible. And although there is still some HGI2 there, you can't see it because the concentration is less and it has reached equilibrium.
And we can even supersaturate it, which I'll try to do lightly. Ooh, getting some yellow. And this is when the HGI is completely in higher concentration than the reactants. And to go back, we just add more mercuric nitrate.